This is a video on trigonometric functions. Just like any other function, well, a trigonometric function is also a function. So we all know sine theta, cosine theta, tan theta. Now, theta is measured in angles, but when it comes to a function, especially in calculus, we do not represent it using theta. Rather, we express it as sine x, cosine x, and tan x. Sticking to the notation of a function that depends on x. So, key thing to remember about trigonometric functions is that functions that are trigonometric are periodic. In other words, they repeat themselves over and over again. For example, if you take a sine function, which is a sine function that varies with respect to x, you can say that when I do it, I've repeated the same curve over and over again. So that is 0, and that is 2 pi. And an important thing, aside from noting that sines, cosines, and tans are expressed in terms of x, the values of measurement are in radians. So anytime we are using a sine function, a cosine function, or a tangent function in calculus, the value of x must be in radians. And radians are pretty much real numbers. For example, pi would correspond to 180 degrees, but it's just pi as a real number. 2 pi would correspond to 360 degrees, but 2 pi is just a real number. The period of a sine function right here is 2 pi. So every 2 pi distance, the function is going to repeat itself. In other words, the shape would be exactly the same. So right there, that is pi, and so whatever I see between 0 and 2 pi would be exactly the same between 2 pi and 4 pi. And likewise, whatever I see between 2 pi and 4 pi would be exactly the same between 4 pi and 6 pi. And that is what we mean by periodic. So a sine function has a period of 2 pi. In other words, sine x would equal sine x plus 2 pi. No matter what value of x you plug in, this particular identity would always be satisfied, because sine x is equal to sine x plus 2 pi, and it is 2 pi periodic. So for instance, whatever I see here at 0 is exactly the same that I would see at 2 pi. Whatever I see at pi is exactly the same that I would see at 3 pi. So at pi over 2, I have a value of 1, and I add 2 pi to it, and at 5 pi over 2, I would have 1 again. So sine functions are 2 pi periodic. Just like a sine function, a cosine function is also 2 pi periodic. In other words, cosine of x would simply equal to cosine of x plus 2 pi. The nature of a cosine function, however, is slightly different from the sine function. If you observe a sine function, the sine function, when x is equal to 0, had a value of 0. But a cosine function, on the other hand, would have a value of 1 when x is equal to 0. But the function is still periodic. So when x is 0, the value of the function, cosine function, it is 1, and the lowest value that it can take is still -1, and that value right there would be pi, and the next time it becomes 1 has to be at 2 pi, because it is 2 pi periodic. So this is the curve that you can see for a cosine function between 0 and 2 pi, and between 2 pi and 4 pi you would see a similar curve, and it is going to repeat over and over every 2 pi spacing. So at 0 we had a value of 1, at 2 pi we will have a value of 1, at 4 pi we would have a value of 1, at pi we would have a value of -1, add 2 pi to it, at 3 pi we would have a value of -1, add 2 pi to it, at 5 pi we would have a value of -1. If you observe here, both sine and cosine have a domain that is between -infinity and +infinity, but it is 2 pi periodic. The same curve is going to repeat over and over again, but you could use any value between -infinity and +infinity. The range, however, is between -1 and +1. In other words, the sine function and the cosine function will not exceed 1. It is not going to exceed -1. Of course, this is going to change if you multiply it by some constant, but typically in its natural form, sine function and cosine function is not going to exceed 1. It is not going to go below -1. We all know that tan of x, or the tangent of x, is sine x over cosine x, and this is sort of, a rational function, and we've got the function in the denominator, and we know that cosine is going to become 0 for some value. It's obvious from the previous curve. Cosine of x will be 0 if x is equal to pi over 2. It is 2 pi periodic, so whatever I see at pi over 2 is also going to repeat at the next period. Pi over 2 plus 2 pi would be 5 pi over 2, and add 2 pi again, I'd have 9 pi over 2, and so forth. Since it is going to become 0, the tangent function will actually have vertical asymptotes. Anytime the denominator becomes 0, the tangent function is going to become infinity. So it is an interesting looking function. Clearly it is going to have asymptotes. And that is a tangent function. And if you guess it correctly, this is 0 naturally, and that would be pi over 2. When it is when x is pi over 2, tan pi over 2 is infinity. If it is negative pi over 2, tan negative pi over 2 would be negative infinity. And it is going to repeat over and over, so But I forgot to add 3 pi over 2 here. So pi over 2, 3 pi over 2, and add another pi, 5 pi over 2 would all result in an asymptote. If you look at the difference here, the difference here is pi. So the tangent function is not 2 pi periodic, the tangent function is pi periodic. In other words, it repeats with a period of pi. And in addition, the tangent function has vertical asymptotes, at x is equal to negative pi over 2, pi over 2, 3 pi over 2, 5 pi over 2, and so on. So these are the trigonometric functions that are commonly used in calculus. But of course, you could take the reciprocal of each of these functions. You could have 1 over sine x, which would be cosecant x, 1 over cosine x would be secant x, 1 over tan x would be cotangent x, or simply cot x. An important note is that an inverse function or inverse trigonometric function is not the same as the reciprocal functions above. In other words, the one that I just listed. In other words, cosecant, secant, and cotangent are not inverses of sine x, cosine x, and tan x. So what would then be the inverse of a sine function? So we denote the inverse functions of sine, cosine, and tan as sine inverse of x, or arcsine of x, cosine inverse of x, or arc cosine of x, tan inverse of x, or arctan of x. I want you to observe a sine function and its inverse carefully. Now, we know something about an inverse function. For a function to even have an inverse, the function has to be 1 to 1. What do we mean by 1 to 1? If I have to draw a horizontal line through a function, the line must actually touch the function at exactly one spot. If it doesn't happen, then it is not going to be a one-to-one function. So how do we guarantee that we have an inverse? If I draw a horizontal line through the sine function, for instance, I'll just draw right there, and it fails the horizontal line test fabulously. It touches there, so it's touching at 2 different places. So this actually is not one-to-one, and so sine and cosine function will fail the horizontal line test unless there's something you should remember from algebra, unless we restrict the domain, then we cannot have an inverse. Now, what do I mean by restricting the domain of sine function? To make this obvious, I am going to draw the sine function from the negative side, and of course not great at drawing the function, but so that's a sine function, and I have 0, I have pi, 2 pi, 3 pi, negative pi, pi over 2, negative pi over 2, and so forth. Now, if I drew a line, as I did before, a horizontal line, it is going to fail the test. So it's going to be not 1-to-1. But if I restrict the domain, for example, if I restricted it between negative pi over 2 and pi over 2, in other words, I consider that particular interval that's between negative pi over 2 and pi over 2. So it is that piece, that curve right there. If I drew a horizontal line through that curve, it is going to touch at exactly one point. So by restricting the domain between negative pi over 2 and pi over 2, the sine function could have an inverse. So if you look at it, the value of x is between negative pi over 2 and pi over 2. The value of y is between positive 1 and negative 1. And recall, the domain of f of x is the range of f inverse of x. And the range of f of x is the domain of f inverse of x. So have sine inverse of x here. The domain that I've restricted is between minus pi over 2 and pi over 2. So now the domain becomes the range, so sine inverse of x will be between minus pi over 2 and pi over 2. And the range is going to become the domain. The range of sine x is between negative 1 and 1. So that's going to become our domain, negative 1 and 1. And if you sort of looked at it from the y-axis, you can visualize the curve. It'll be flipped, and you would get something like this. And that would be the inverse of a sine function. We call it the arcsine, or the sine inverse of x. So what we know is the inverse function of a sine would have a domain that is between negative 1 and 1, and its range is going to be between minus pi over 2 and pi over 2. Same rule applies with cosine. We all know at 0 the cosine is 1. So we have something like that, and it's going to go that way, and that is our cosine function. Just like the sine function, I draw a horizontal line right now. It's going to cut through two different points, and it is not going to be a one-to-one function. Now we've got to make it 1-to-1 by restricting the domain. Now, how shall I restrict the domain? I can't restrict it between, well, this is 0 and pi over 2. That would be pi, and 2 pi, 3 pi, 4 pi. Excuse me, I actually have it wrong here. Go backwards. That would be 2 pi and 3 pi and 3 pi and so forth. So if I have it's negative pi. If I draw a horizontal line such as that, it is going to touch at 2 different points, and it is not interesting. It doesn't pass the horizontal line test. You cannot have an inverse. Now, how should we restrict the domain? There are multiple ways to restrict it, but the easier way is to restrict it right here between 0 and pi. In that case, I would have a curve of this sort. So that will be the portion of the cosine function which is going to satisfy the horizontal line test by restricting the domain. So the restricted domain here is between 0 and pi. And on that interval, the range will be between -1 and +1. That's exactly what we have here. That is -1 and that is +1. So as always, the range becomes the domain, and the domain becomes the range. So the range is -1 to 1 for a cosine, so that becomes the domain. We'll have -1 to 1. And the domain is 0 to pi. That's going to become our range. I'll have 0 over here and pi over there. And if I flip the axes, that's how we find the inverse. If you flip the axes, you would see that the cosine function would look something like that. It is not drawn accurately, but a calculator would do a fantastic job, better than what I'm doing. So that is an inverse cosine function or arc sine function. In a similar manner, arc cosine function. In a similar manner, you could get arc tangent, arc cosecant, secant inverse, cotangent inverse, and so forth. All of these functions are readily sketchable using a calculator, a scientific calculator such as TR-84, and you can look at the shape clearly. I'm going to quickly demonstrate the sine, cosine, tangent, inverse tangent functions using a calculator. All these functions are available here. The sine, the cosine, and the tangent. Those are the most commonly used trigonometric functions. Of course, we have cosecant, secant, cosecant inverse, secant inverse, cotangent, and so forth. Those functions, I don't believe, are available in a TI-84 plus calculator. One can find the cosecant and the secant and the cotangent by just doing the reciprocal. So let's start with a sine function. We know the sine function is 2 pi periodic, so it repeats every 2 pi distance or interval. Let me set the range first. I'm going to set the x value is between negative 2 pi, negative 2, and I believe there is a pi button, second, and the control or caret symbol, and I am going to go all the way up to positive 2 pi, so 2 and pi. Knowing the domain and range is a great thing because that sort of helps you in identifying the window of the sine and the cosine function. So the minimum value of the sine function is negative 1, the maximum value is 1, and if I graph it, so I'm going to go back here and select sine and x and graph. And there we have it. That is a nice sine function between 0 and 2 pi. That is something that I drew before, but as you can see, this is doing a much better job than what I drew a while ago. This is between negative 2 pi and 0, 2 pi interval, 0 and 2 pi interval, and it is 2 pi periodic. It is 1 at pi over 2, it is negative 1 at 3 pi over 2, 0 at pi, 0 at 0, x value. We could do the same. I'm going to keep the same picture, same window, and I'm going to add a cosine function to it, cosine of x, and graph, and you can see it has shifted. The cosine function has a 1 at 0 and it has a negative 1 at pi. But at the same time, the cosine function is just as 2 pi periodic as the sine function. We've got to be careful when we try to graph and understand a tangent function, because the tangent function has asymptotes, and we've got to account for those asymptotes while setting the window. We know it is between negative pi over 2 and pi over 2, so that is the domain of a tangent function, so I will have negative pi over 2 and positive pi over 2. And the range is between negative infinity to infinity, so I'm just going to set it to a really large value. Negative 100 is a really small value, and a really large value to represent positive infinity as 100 and negative 100 for negative infinity. And if I graph it, there's nothing here because I haven't defined the function. And if I graph it, tangent of x, graph, and you can see it is the function, that's the asymptote, and it's not very clear. It doesn't look like the function that I sketched. It is because of the y values. If I adjusted the window and if I went from negative 10 to positive 10, perhaps I will get a better picture. So I've adjusted the range, and if I graph it now, oh, that looks sort of like the picture that I drew a while ago in this video. And lastly, we could also sketch the sine inverse, cosine inverse, and tangent inverse functions, and I'm just going to show you the sine inverse and cosine inverse part because that's what we did. We've got to realize that the domain and the range are switched. So for a sine inverse function, it's between negative 1 and 1. The range is between negative pi over 2 and pi over 2. Negative pi over 2 and pi over 2. Pi over 2, and let's define the function. I'm going to clear it, and second sine, it's going to get me the sine inverse function, and close paren and graph. And that is the picture that I drew a while ago. Similarly, I could go and change the range. We know the range of a cosine inverse function is between 0 and pi, so the lower value now becomes 0. Got to change the window to 0 and pi, so I'll have pi here and graph, and that is exactly the curve I have here to my right on the screen. So that's how you would sketch these functions, trigonometric functions, using LTI-84 calculator. Thank you for watching the video.